Boolean algebra introduced by George Boole. So we define the Boolean algebra. Used for logics. Let B any non-empty set, addition and multiplication, B2 binary operations, then B under addition and multiplication. So this is the algebraic structure. Is said to be Boolean algebra if it satisfies the properties we take as B1. First property, which is denoted as B1, and the name of the property is closure property. Let A be the element of Boolean algebra B, that means non-empty set B. So then A plus B is also belongs to B, and A into B also belongs to B. So for satisfying these two properties, that means closure under addition and multiplication, these two. Second, we take as B2. B2 is commutative property. For commutative property, we take again two elements. Let A and B be two elements of B. So then A plus B is equal to B plus A, and A into B is equal to B into A. So this is for commutative. So commutative under addition and multiplication, both operations will satisfy these two. Now we move to the third property, which is B3. B3 is a distributive property. B3 is distributive property. So for distributive property, we take three elements. A, B, C, be three elements of Boolean element, that means set B. So A plus B into C is equal to A plus B into A plus C. Addition is distributive with respect to multiplication, and multiplication is distributive with respect to addition. So this can be written A into B plus A into C. So this is a third property, denoted as distributive, or when we do the questions, so we understand these one, that is B1, B2, B3 by using B1, by using B2, by using B3. Remember these. Next property B4, existence of identity. For identity, let A be the element of Boolean algebra B. So A plus 0 is equal to 0 plus A equal to A. So here 0 is the additive identity. And when we take 1, so A into 1 is equal to 1 into A is equal to A. So here 1 is the multiplicative identity. So 1 is multiplicative identity. So in Boolean algebra, we take only two numbers, binary numbers, 0 and 1. When you draw the trust tables, also take as 0 and 1. And last property 5, complement law. That means complement property. This is the property number 5. So complement property or A plus A complement is equal to 1 or A into A complement is equal to 0. These are the two properties. So A belongs to B, so its complement also belongs to B. Its complement also belongs to B. So A plus A complement equal to 1 or A into A complement equal to 0. So these are the 5 property. If any set satisfies, so then set is said to be the Boolean algebra. 6 properties we write as 0 is not equal to 1. So never the identity, additive identity is not equal to multiplicative identity. The number 0 is not equal to 1. So basically we satisfy all 5 properties. So then we write as B under addition, multiplication is said to be Boolean algebra. So if satisfy these properties, so any set is said to be the Boolean algebra. Now we can take an example. For example, show that the set B having two elements 0 and 1 under addition and multiplication is Boolean algebra. Addition and multiplication is Boolean algebra. Or this question we can write in this form: take two elements 0, 1 and taking two binary operations. Okay, for Boolean algebra we use only binary digits 0 and 1. So here we show 0, 1, we having two elements 0, 1 under addition and multiplication is Boolean algebra. So for solving this, just we draw two tables. So on the basis of these two tables, we can say that how many properties are satisfied. So that means for addition, we have two elements 0 and 1. So under multiplication, we are also having two elements 0 and 1. So we write 0 and 1. So we perform the operation addition. So 0 plus 0, that means this 0 plus 0 gives us 0. 0 plus 1 gives us 1, 1 plus 0 gives us 1, and 1 plus 1 we write as 1. So in binary, 1 plus 1 equal to 1. Same as 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, and 1 into 1, 1. So this is the table. One plus this one, yes, 1 plus 1, 1. We read only binary digits 0 and 1. Here in Boolean algebra, we follow the binary number system. So we see that all the elements of this table belongs to B, and all the element of this table also belongs to B. So that means when we perform the operations addition and multiplication, the element of both the tables are belongs to B, only getting 0 and 1. So when we satisfy property B1, easily satisfied. So B1 means closure. So for closure, we take suppose A equal to 0 and we take B equal to 1. So when we perform addition, so 0 plus 1 gives us 1. So 1 is the member of B. When we perform into, so we write as 0 into 1, so gives us 0. So 0 belongs to B. So that means closure satisfied. You can take a same element, that means you can take A equal to 0, B equal to 0, or you can take A equal to 1 or B equal to 1. Satisfy for all the, because we construct the table, that this table shows that commutative and associative and distributive are satisfied. No need to do the same thing again and again. When we take for B2, B2 is commutative. So same we can choose as A equal to 1 or B equal to 1 you can take, or A equal to 0, B equal to 0 you can take as for your choice the elements. And when we write A plus B gives us B plus A, and A into B gives us B into A. So commutative satisfied. And similarly for distributive, we take 3 elements. So for taking 3 elements, we take A equal to 0, we take B equal to 1, or we take C equal to 1. So first we write as A into B plus C. So A into B plus C gives us A into B plus A into C. So here we write as 0, 0 into 1 plus 1 is equal to 1 in 0 into 1 plus 0 into 1. So 1 plus 1 is 1. So 0 into 1 equal to 1 into 0, 0, 0 plus 0. So 1 into 0, so this gives us 0 equal to 0. Means satisfied. So similarly, you can proceed for addition. Addition means you write as A plus B into C. So A plus B into C, you write as A plus B into A plus C. So this also satisfied. Okay, so distributive satisfied. We write as B4. B4 means identity. So you can take one element as per your choice. So that means we can take A equal to 1, and correspondingly the identity element. So identity element under addition is 0. So we write that A plus 0 plus 0 plus A equal to A. So when we write 1 plus 0 equal to 0 plus 1 equal to 1. So this one is also belongs to be the additive identity satisfied. And for multiplicative identity, we write as 1 into 1 equal to 1 into 1 equal to 1. So 1 is also belongs to B. So that means fourth property also satisfied. Now write for fifth one, complement. So for writing the complement, we write the complement. So we have element A and write these complement. Complement denoted as A complement or A dash. So 0 and 1. We have only 2 elements. So what is the complement of 0? 0 complement is 1, or 1 complement is 0. In binary, 1's complement is 0, 0 complement is 1. So So when we see that we calculate the complement, this complement is also member of B. So when we perform A plus A complement equal to 1, so you can take A equal to 0 and its complement equal to 1 gives us 1. When we take A equal to 1 and its complement is 0, so gives also equal to 1. So satisfy both the cases. So this is satisfied. And similarly, when we take A into A complement, so A equal to 0 and its complement equal to 1 gives us 0. And this also satisfied because second complement, so this is the first one. Our second one, we have A into A complement equal to 0. This is the second complement. So this also satisfied. So that means complement also satisfied. So we can say that if you want to write B6, so then you can write that means 0 is not equal to 1. So B under addition and multiplication is Boolean algebra. So simplest example, and so B having only two elements 0 and 1, 3 digits. So is the Boolean algebra under addition and multiplication. So after this question, that means we have some theorems related to Boolean algebra. So we start with the theorem 1. For every element of a Boolean algebra B, A plus A equal to A, or second is A into A equal to A. This is also called idempotent law. Also called the idempotent law. So A plus A equal to A or A into A equal to A, we shall prove that by using the Boolean algebra definition. So when we do the first one, so taking LHS part of the question, so that means taking LHS. So we have LHS A plus A. So this A plus A you can write as, so we can write this A plus as A plus A into 1. Okay. So by using which property you write this one? So by using B4. By using B4. B4 क्या कहती है हमारी प्रॉपर्टी? B4 कहते हैं A, that means existence of identity. A into 1 equal to 1 into A equal to A. So A, this element we can write in this form, A into 1. Okay. So here we write by using B4. Now next step, we write this one as A plus A. So this one we can write as A plus A complement. We can write as A plus A complement. So by using which property? So here we use B5. So using B5. So by using B5 we write this one. So A plus A into A plus A complement. Now next we have this one. So for simplifying this, we write the B3. We use the B3. B3 means distributive. So reverse distributive we use here. So how to write this one? So we can write this one as A plus A into A complement. So here we use the B3 by using B3. By using B3 हमने reverse distributive लगाया है. Now next step, A plus A into A complement. So A into A complement 0. So A into A complement 0. So we write as A plus 0. So for this we use by using B5. So by using B5 we write 0. and a plus 0 we can write as a. So by using b4, so we can say that a plus a is equal to a. So we remember all the property v1, v2, v3, v4, v5. So on the basis of that you can prove this one. A plus 0 or b4. Okay, sorry, b4. How we write b4? कॉम्प्लीमेंट इसको लिखा है ना, a इंटू कॉम्प्लीमेंट, a इंटू ए कॉम्प्लीमेंट को 0 लिखा है, वो b5 की हेल्प लिए, इसके लिए हमने लिखा है a इंटू ए कॉम्प्लीमेंट इज 0 बाय यूजिंग b5 की हेल्प से हमने इसे लिखा है, और a प्लस 0 इक्वल टू a, इसको हमने b4 की हेल्प से लिखा है. ओके, similarly try to solve second part, a into a equal to a. Second part is a into a equal to a. So taking LHS part, so we write as a into a. So you can write a into a. This one as, in first one we just multiply by 1, here we add 0. Okay, so remember how to solve this one. So you can write this as a into a plus 0 by using b4, so this we can write as a into a plus, so this 0 we can write as a into a complement, here we can write as by using b5, and again we use the distributive, so we can write as a into a plus a complement, so a into a plus complement, so this for we write as by using b3, or a plus a complement equal to 1, so a plus a complement equal to 1, so here by using b5, and a into 1 equal to a, or this by using b4, so we can write as a into a is equal to a. Okay, so this is the first theorem, and similarly for second theorem, for Boolean algebra B, a plus 1 equal to 1 and a into 0 equal to 0. A plus 1 equal to 1 or a into 0 equal to 0. So proving first part, taking LHS part of this, so we write as a plus 1. So we have to prove that a plus 1 equal to 1. So we can write this 1 as a plus a complement. So we write this one as a plus a complement. So we can write by using b5, and previously that means theorem 1 we have proved a plus a equal to a. So previous theorem we have proved that means a plus a equal to a. So a plus a equal to a, we write as a complement. So here we write as by using theorem 1, or we can say that idempotent law. Theorem 1 or idempotent law. So here we have a plus a complement. So a plus a complement equal to 1. So we again write by using b5. So a plus 1 is equal to 1. And similarly, for second part, taking LHS of second part, we write as a into 0. So this a into 0 we can write as a into a complement. So this we can write as a into a complement, or a into a equal to a. So a into a complement. So here by using theorem 1, a into a equal to a. So a into a complement equal to 0. So by using B5. So we write as a into 0 equal to 0. So this is the theorem number 2. And next theorem number 3. So for theorem number 3, for any element of Boolean algebra B, prove that first one, a plus a into b equal to a, or second part, a into a plus b equal to a. So this is the theorem number 3, a plus a into b equal to a, or a into a plus b equal to a. So when we prove first part, taking LHS, so we write as a plus a into b. So what is our next step? A dot. Here we use a B4. A dot. Here we use by using B4. So this step we can write as A into 1 plus A into B. Okay. So this A into B we write as it is, but this A we can write as A into 1. So A into 1. Now we use the distributive law. So when we use the distributive law, so you can write as A into 1 plus B. So A into 1 plus B. So here we use by using B3. By using B3. Now we remember this. When we take a two element, two or three or more element which belongs to Boolean algebra B. Okay, for any Boolean algebra B, A or B belongs to B. So second theorem क्या कहती है? Second theorem 2, we write as a plus 1 equal to 1. So a plus 1 equal to 1. So for second set, that means when a belongs to b or b belongs to also b, so we can write as b plus 1 is also equal to 1. So remember this. So b plus 1 is also equal to 1. So here we use theorem 2. So this b plus 1 we write is equal to 1 by using theorem 2. So a into 1 equal to a. A into 1 equal to a. This is by using 4, b4. So this one, a plus a into b is equal to a. A into b is equal to a. So this is the first part. Similarly, for second part, taking the LHS of second part, so we write as a into a plus b. So a into a plus b, as per first part, second part we can take as, in first part we take as in 1 a into 1. So here we can take as a plus 0. That means additive identity. A plus 0 into a plus b. So we use that distributive law. So this we can write as by using B4. B4 की हेल्प से हमने ये लिखा a plus 0. अब डिस्ट्रीब्यूटिव लॉ अप्लाई करेंगे. सो डिस्ट्रीब्यूटिव लॉ के लिए क्या कर लिखेंगे सर? a plus 0 into b, 0 into b. So we write as by using b3 and 0 into b 0. So 0 into b equal to 0 because आइडेंटिटी के लिए सॉरी आइडेंटिटी नहीं, थ्योरम 2 हमने सॉल्व किया. बैक टू द थ्योरम 2. थ्योरम 2 का जो सेकंड पार्ट था, थ्योरम 2 का सेकंड पार्ट क्या था? a इंटू 0 इक्वल टू 0. तो जब a और b दोनों ही बुलियन अलजेब्रा b के मेंबर होंगे तो a इंटू 0 होगा तो भी 0 होगा और a इंटू b इंटू 0 होगा तो भी 0 होगा. तो सेम हियर में वी यूज द थ्योरम नंबर 2. So this we can write as a plus 0 by using theorem 2, or a plus 0 equal to a by using b4. So these are the theorems, and we take last theorem. Theorem number 4. The complement of each element of Boolean algebra B is unique. That means complement cannot be 2 or 3. Complement is always of any non-empty set is always unique. That means 0 complement is 1 or 1's complement is 0. Cannot be 2 or 3 complements of any. So for proving this theorem, we take a contradiction. That means we take one element and one element have 2 complements. Okay. So we shall prove that both complements are equal. If both complements are equal, so that means we can say that the complement is unique. So now proving this, we consider let us consider an element A which belongs to the Boolean algebra B, and again let A has 2 complements. Assume करके चल रहे हैं हम कि A has 2 complements. These 2 complements are A1 complement and A2 complement, which are also belongs to B. Okay, so we assume that A having 2 complement, so which are also belongs to B. Now to prove that A1 complement equal to A2 complement, अगर हम ये प्रूव कर देते हैं कि जो दो कॉम्प्लीमेंट लिए हैं वो दो नहीं है बल्कि एक ही कॉम्प्लीमेंट है, दैट मीन्स वी कैन से दैट द कॉम्प्लीमेंट्स आर यूनिक. अदरवाइज okay, that means having more than one complement. So our purpose to prove that when we are taking 2 complements, so that are not 2 different complements, that are only 1 complement. So we shall prove that A1 complement equal to A2 complement. So for proving this, so we take as we know that by definition of Boolean algebra, by definition of Boolean algebra, we use the property B5 here. By property B5. So by using property B5, we can write as complement property. So complement property says that A plus A complement. So complement हमने क्या लिया A का A1 complement. A plus A1 complement और you can write as A complement plus A equal to क्या होता है? A plus A complement equal to 1. So this is by using B5. This is for addition and similarly for multiplication. A into A1 complement or A1 complement into A, this equal to 0. So this is the equation number 1. This have taken from the definition, and for second complement we write as A plus A2 complement equal to A2 complement plus A is equal to 1, and similarly for write A into A2 complement plus A2 complement into A, this is also equal to 0. So these are the two equations we have taken from the definition of Boolean algebra. Now our purpose to prove that A1 complement equal to A2 complement. So now we take the LHS part. Now take LHS. तो LHS क्या है हमारे पास? Only A1 complement. तो हमारा पर्पज है प्रूव करना A1 complement equal to A2 complement. So A1 complement of this A1 complement we can write as this equal to we can write as A1 complement into 1 लिख सकते हैं. So okay, so by using B4, next we can write as A1 complement into 1. This 1 we can write as by using 1 or 2. Equation 1 or 2 से क्या लिख सकते हैं? एक तो लिख सकते हैं 1 plus A plus A1 complement. So or second term we can write as A plus A2 complement. So we using equation number 2. So this equation we can use. So we can write as A plus A2 complement. A plus A2 complement. So this equal to also 1. So we can write it by using equation number 2. So equation 2 से हमने 1 को लिखा है A plus A2 complement. Now we use the distributive law. So when you use distributive law, so you can write as A1 complement into A plus A1 complement into A2 complement. So this we have done by using B3. Now A1 complement into A. अब A1 complement into A ये कहाँ से लिखेंगे हम? यहाँ से इक्वेशन नंबर 1 से 0. So this equal to 0. So 0 plus A1 complement into A2 complement. So using equation number 1. Equation number 1 से A1 complement into A equal to 0. Now this 0 can be written by using equation number 2 as A into A2 complement. So this can be written as A into A2 complement plus A1 complement into A2 complement. यहाँ पे हमने यूज किया इक्वेशन नंबर 2 को. इक्वेशन 2 से हमने लिखा A into A2 complement. अब फिर अगेन we use the distributive law. So when you use distributive law, so A2 complement are same. So we can write as A plus A1 complement into A2 complement. So distributive law we use for this. Now अब A plus A1 complement. A plus A1 complement क्या है? 1. So A plus A1 complement by using the equation number 1 is 1. So A plus A complement is equal to 1. So this is equal to 1. So 1 into A2 complement. So here we use by using equation 1 or 1 into A2 complement. So 1 into A2 complement equal to A2 complement. So A2 complement. So this using V4. So we can say that A1 complement equal to A2 complement. So that means the complement cannot be different. So complements are same. So that means hence the complement of any element are unique. दो डिफरेंट कॉम्प्लीमेंट लेके चले थे हम और हमने दोनों को इक्वल दिखा दिया, सो दैट मीन्स कॉम्प्लीमेंट्स ऑलवेज आर इन यूनिक, सो कैन नॉट बी डिफर एंड ओके. सो थैंक यू स्टूडेंट्स. एक बार रिवाइज कर लेना, आज शाम को मैं आपके लिए ठीक है क्विज़ेस ओपन कर दूंगा. एक क्विज तो ओपन है, सरप्राइज टेस्ट ओपन कर दूंगा और प्लस असाइनमेंट तो ओपन है.